Alright, so welcome back to the next part in a YouTube video series on Power and Workflow, basically a series of tutorials to basically introduce some simple features that you might find useful in our workflow framework. So today we're going to be talking about type hinting and why it might be useful and how it can turn workflow objects into strongly typed workflows and why you might want to use them. Okay, so without further ado, let's get started. So as always, we're going to import the workflow object from Power and Workflow. And we're going to simply recycle the two nodes that we had defined in the first part of our video series, Hooke's law and compute strain. Okay, and here we have the force and the spring constant for Hooke's law, and we're going to return a displacement, and the compute strain, which takes in a displacement and the original length, to return a strain. Okay, so we have these two, and we're going to say workflow anything, and we're going to also add this additional flag that basically says we're going to remove all of the files associated with this workflow before every time we run. Essentially, every time we run this workflow, it's going to start from scratch. And we're going to say Hooke's law is equal to Hooke's law, force equals to 1000, spring constant equals to 2000, compute strain equals compute strain, displacement equals to the output of the Hooke's law node, outputs, and the output is called displacement, so on the outputs we simply choose the displacement channel, and the second bit, which is the original length, let's just go with 1. And we're going to write this in, but we're going to comment it out for now because I want to show you that this workflow doesn't run for the moment because original length is not defined. Okay, so original length. Okay, and we can draw this workflow before we run it to look at what we've done. Zoom out a little bit so we can visualize the entire workflow, and we can see that it consists of 2 nodes. Okay, 1, 2. And we can see that by the outline on these nodes, that both of these nodes have not run yet. Okay, so if it has run or failed, it will have green or red respectively, and here we see neither. And if we now run the workflow, we can see now that these 2 objects now have a green outline. Okay, so indicating that they both ran successfully. Now I will show you why you might want to turn your workflows to be strongly typed. So now let's say somewhere along the line I made a mistake or some alteration to my Hooke's law node that somehow turned the displacement into a string. Right? So displacement equals string displacement. And we're going to say that this node is now quite expensive to run. So in many cases in material science or any kind of science, functions can take from anywhere from seconds to hours to even days or weeks to run. And we're going to simulate this computational expense by the sleep function. We're just going to start with a sleep of 10 seconds here because I don't have weeks to make this tutorial. And we can say, okay, we can clearly see that this workflow will now not work, but we're probably going to have to wait 10 seconds before we find out that this second node doesn't work because we can't divide a string by a float. All right. So now we're going to define these nodes again. Import the sleep. Redefine the nodes so that we have the computational expense simulation as well as the string conversion in here. And we're going to run it. Okay, and now we're going to have to wait 10 seconds to basically find out that the second part of our workflow doesn't really work. Okay, now it errors out, and here we have the type error, unsupported operand type for string and int, as we expected. So what we can do now is we can draw this workflow again, and we can see that, zooming out again, that this Hooke's law node ran, and then it fed into the compute strain, which then failed. Okay, so now it's in red, indicating that it failed. So we can see that we had to run the first node before we figured out that the second node failed. Now, what you can do is, if you are rigorous with type hinting, so let's say now we indicate that this function outputs a string when we did the conversion. Okay, and we can prevent this from happening by saying that this displacement variable must always be either a float or an integer. Okay, because those are the types that are supported by this division operand type, or you can even say numpy array if it makes sense in the context of your function. But here I'm saying that it must always be a float or an integer. And what parent workflow is now going to do is it's going to traverse the graph for these functions for type hints, and it will immediately notice that in this workflow, I'm going to take in Hooke's law, this output from Hooke's law, and I'm going to feed it into this displacement variable, this displacement argument, and this argument only takes float or int, so it will immediately fail out. Okay, so let's make sure that these type hints are now defined in our functions. We ran this, so now this workflow is strongly typed over here and over here. And instead of waiting 10 seconds to find out that the second part of our workflow is broken, we can immediately run this workflow, and we can see that now it immediately errors out because it found that these two types are not compatible. Okay, so parent workflow, by turning your workflow objects strongly typed, can help you avoid this kind of error in your workflow development. And what we can confirm by looking at the workflow graph visualization is that none of these nodes worked. So we didn't even have to run any of these nodes to find out that this workflow is not going to work. Okay, so turning it back, let's say comment that out. We say now that it's over a float. It's going to be a float. And we're going to run it again. And now we wait 10 seconds. Everything should work. And now life is good again. Okay, so we draw the graph again, zoom out again, and we can see that now it works. Okay, so that's why you might want to turn your workflows strongly typed. It can save you a lot of time in development to prevent weird objects passing around between nodes, and basically enforces good programming overall. Okay, so hopefully you found this useful and motivates some of you to turn your workflows strongly typed with parent workflow. And I will see you in the next part of the video series.